Namaste guys and welcome to the new session of C programming. So today in this video we are going to learn about variables and what are the data types. So in our last video we have seen how we can represent our numbers and we have converted numbers from one to another. We have used decimal number, hexadecimal numbers and our binary numbers and octal numbers. So we have learned pretty good theory in our last class. So in this class let's focus on what are the variables. Now let's start with the coding, but wait, where we are going to store that data. So for that we are going to use our memory. It is nothing but a electronic component used to store data or to read data and write data. Means we can store our data inside our memory and also we can fetch that data. But as we all know, our computer uses binary language to store data inside our memory or to do other operations. Now computer uses a binary language to perform read and write operations, as we all know, but these memories are made up of small compartments and these compartments are capable of storing one bit of data. So our binary language has base of 2, meaning that we can use only 0 and 1 to represent our binary language data. So memory uses same concept, either it will store 1 and or it will store a 0. So this individual entity, it is called as a bit. So this is also one bit and this is also bit. Now our memory has numbers of such compartments and these compartments can be capable of storing bits in each compartment. So in this compartment I can store 1 or 0 at a time. So if I store 1 in this compartment, so I can store 1 in this compartment, I can store 0 in this compartment, I can do this thing randomly 1 0 1 1. So each of these compartment here we are using 8 bit. So each of these compartment they have a specific power. So 2 raised to 0 is nothing but 1. Here 2 4 8 16 32 64 and 128. So these each compartment has a specific set of power inside our 8-bit number. So combined 8-bit number, it is called as a byte. So 1 byte meaning that it has 8 bits. So 8 bits combined they create a byte. Now we can represent any decimal number using these bits. So let's assume I want to represent 9. Now how we can store this 9 decimal number inside our binary format of 8 bits. So to do this, let me just erase this. Now I can use this 8 and 1 to represent our number 9. So I'm going to make this bit as 1 and this bit as 1 and other bit as 0. So this is how I can use these 8 bits to represent our decimal number 9. So what is the maximum number we can represent? So if I make all of these bits as 1, so maximum number is going to be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 is nothing but 255. So this is the maximum number we can represent using our all of the bits inside a byte. So a byte has capability to represent a maximum number of 255. So using such kind of bytes we can represent a larger number or larger set of data inside our memory, or we can store that data inside our memory. Now please note that our computer can store a smallest size of data is of 1 byte. Means if you want to store a smallest size of data inside our computer memory, then we can store only 1 byte of data. And if I want to fetch a smallest size of data, we can use only 1 byte of data to fetch. You cannot fetch a single byte out of a computer, or you cannot store a single byte inside your memory. Our memory has number of such compartments and you can use these compartments to store our byte. So inside one compartment we can only store 1 byte of data. Means this individual compartment can store only 1 byte of data. So number of such compartments in our memory, they are storing bytes of data. So this compartment is capable of storing 1 byte of data. Now this compartment is also capable of storing 1 byte of data, and this and all of these compartments, they are capable of storing 1 byte of data. So if you want to fetch a data from your computer, you can only fetch 1 byte of data. A smallest size you can fetch is 1 byte, or if you want to store a smallest size you can store is of 1 byte. Now if I give 4 of these bytes as a one name, let me say I'm going to name these 4 bytes as a So this concept is called as a variable. Means I'm going to give a label for these 4 bytes as a So label name is A. So we are telling our computer we are using these 4 bytes and we are giving these 4 bytes as a name A. So we can use this name and we can manipulate data inside these memory locations. So this concept is called as a variable. So it is A is a variable name. Now let's understand what is a variable. So variable, it is a label of that memory locations which is used to hold data or to manipulate data during program execution. Meaning that as we named those 4 memory location as a, so this is how we can create a variable and we can give any name you want. So every variable has two properties. First, it has a name and it has a data type. So later I will tell you what is a data type. Just for now, understand our variable has a name and a data type. So to create a variable in our program, we are going to use this syntax. First, you are going to mention name of your data type and then you are going to name your variable. So variable name can be anything you want, but there are certain types of rule you have to follow while naming your variables. So as I told you, variable, if I name these 4 locations as A, so I'm creating a variable of 4 bytes and naming it as a. Now to name a variable, we have to follow certain types of rule. The first rule is a variable can consist of alphabets, digits and underscore. To name a variable, you can use alphabets and digits and underscore. The next rule is the name of the variable can begin with an alphabet or an underscore, but it cannot start with a digit. Meaning that if I want to name a variable as 8 box, then this is invalid inside our C. You cannot take a initial as a number and name a variable. So if you want to write this, you can write box 8 or you can use your number at any position you want but not at the initial position. But you can use underscore and your alphabet. So if you name your variable as box, it is fine. If you want to name your variable as underscore box, then also it is fine, but you cannot use a number as a initial of your variable. The third rule is variable names must not contain any white spaces, meaning that if I want to name my variable box space 8, so this is not possible. So this is invalid case inside our C compiler. So to name your variable, you can, so to give your space, you can use a underscore like box underscore 8. So this is a valid case, but you cannot give a white space in between your names. The next rule is avoid using reserved words or keywords like printf, int, include. If you remember in our first program, we have used all these keywords except this int one. So I will later tell you what is this int. So to print our text, we have used our printf, and to include our libraries, we have used our hash include, or such kind of keywords which are available inside our C, you cannot use them. So there are around 32 keywords inside our C. So if you use those keywords as a variable name, it will be a invalid case and it will throw you a error. Now let's understand what is a data type. As I have told you, a variable has a data type and a name. So we have understood how we can name a variable using following few rules. Now what is a data type? So data type, it is a classification that specifies which type of value a variable can hold. Means a data type, it is a classification that tells us which type of value a variable can hold. Means if I want to store numbers, I have to use certain type of data type, and if I want to store alphabets, I'm going to use certain type of data types. If I want to store decimal numbers like 3.2, I'm going to use certain type of data type. So there are 3 types of data types. I'm going to explain them one by one. First type of data types are character data types, and to use these character data types, we have to mention a keyword called char. So when you want to declare such type of data types, you have to use this keyword char. So now using our char, you can allocate 1 byte of data inside our memory. So as I have told you, every compartment is capable of storing 1 byte. So if you want to allocate a compartment, you can use char data type to store 1 byte of data. So these char data types, they usually store alphabets like A. If you want to store alphabets like A, B, C, D, and all the digits from 0 to 9, and if you want to store symbols like hash and like add symbol. So such kind of cases you can use character data type because it is of 1 byte, and using character data type we can tell our compiler for these cases you can allocate 1 byte of data. So the second type of data type, it is a integer type, meaning that as you all know integers are nothing but numbers. To use this integer type data type we have a keyword called int. Whenever you are going to store any numbers you can use this integer type data type. Now this data type has a size of 4 bytes, means using our integer data type you can store up to 4 bytes of data. Means whenever you are going to use this integer type of data type you can store 4 bytes of data. So inside this integer data type you can store any numbers you want, like 0, 12, 110. So such kind of numbers you can store inside our integer. But now inside this integer there are certain type you can use. Now to store only positive numbers, what I'm going to do, I'm going to use one keyword called unsigned. So whenever I'm going to consider only positive numbers, I'm going to use keyword unsigned int. So when I write these keywords, I can use or I can store only positive numbers inside our variable. So let's say I am creating a variable a. Inside this variable a, now I can only store positive numbers. Our next case is signed. So using our signed int, we can store both positive numbers as well as negative numbers. So as a default, this if I write only int, it default known as a signed int. If you only write int, you can store both positive and negative numbers. In case you want to specify that to use positive as well as negative number, you can write this keyword signed. And if you want to store only positive numbers, you can use this signed keyword. So these are called as a modifiers for our integer. So next you can make half of the size of these integer using our another keyword called short. So if you write short int and your variable names, meaning that now integer size has become of 2 byte. So to create a half of that size, you can use a short keyword, means now our integer is now capable of storing only 2 bytes of data. So when in the case when you want to double this size, you can use long keyword. So if you write long, you can long int, you can store up to 8 bytes of data. So if you want to double the size of, so if you want to double size of this integer, you can use long, and if you want to make half of this integer size, you can use our short. So this is all about our integer type. Now let's move on to our floating points. In floating points there are two types. First one is float and second one is double. So size of our float keyword is of 4 bytes and size of our double is of 8 bytes. So size of this data type is 4 bytes and size of double data type is of 8 bytes. Now for this float you can store any decimal numbers like 3.4, 8.2 or 4.258 up to 6 precision point, meaning that if I in this float data type you can store up to 4 precision point, meaning that inside this float you can store a single precision floating point number, meaning that you can store up to 6 digits after a decimal point like 0 0 0 0 and 0. So let me take 2.00 up to these decimal points you can store inside our float. And if you want to get a more accurate number until 12 spaces, you can use our double. So in both cases for pointing we can normally use float, or if you want to more accurate number you can use our double. So this is how our data types work. So data types basically they tell our compiler to allocate a specific amount of data inside our memory. So if I write character data type and our variable name, let's assume I name our variable as a. Now this statement will allocate 1 byte of data inside our memory, and it is going to name that 1 byte as a. So this is how our variables and data types works. So for integer, let me write, if I write int a, means this is going to allocate 4 bytes of data, and it is going to name these 4 bytes as a. So this is called as a variable, and a data type, it is telling our compiler to allocate a specific amount of bytes inside our memory. So this is a chart of data type. As you can see here, we can use the boolean data type, but usually it is only considered for to write true and false value. We don't use it much, but you can remember using our boolean also, it has a 1 byte of data space. Inside our boolean, only possible values are true or false. And our next is our character. As I have told you, it has a 1 byte of space, and you can store any alphabets or symbols or number from 0 to 9 inside our character data types. So our integer has 4 bytes of data size, and we can store any number inside from this range. And for float also, we have data type size is 4 bytes, so we can only add single precision number inside our float. And for double precision, we can use 8 bytes of data using our double keyword. So this is a chart. You need to remember which data types can do what kind of operations. Now inside our computer, we can check size of our data type. Means using this size of operator, we are going to check size of every integer, character and float and double. Now it is used to determine size of a data type or a variable in the form of bytes. Means if I write a variable name as an argument inside our size of operator, it is going to show me the size of that variable, and it returns the size of a operand at a compile time. Means whenever we are going to compile our program, at that time only it will return the size of a operator. So we have to use a specific syntax to do that operation. So as you can see here, we have to use this keyword size of, then a braces, and inside these braces we can write our operand name, meaning that we can also write int inside this. We can write a variable name, let's say a. So let me show you how we can use it. So as you can see here, in our last program we have printed this string, hi, welcome to C programming. So now we are going to write another program to check sizes of our data types and a variable, and how we can create a variable and how we can use our data types. Now you can find this, and you just have to left click and create a new file, or else you can click on this symbol and you can write a name. So I'm going to name variable and data type dot c. So don't forget to write dot c extension. After clicking enter, you can observe the new windows had appeared. Now we are going to write the same statement, int main, because our main program execution starts from int main. Now here, let's create one variable. As I told you, our variable has two properties. It has a data type and it has a name. So you have to use the variable syntax. Now we have to mention first data type name. So let me create one integer type of data type. So I'm going to use our integer data type. So I'm going to mention that keyword int and space. I'm going to name our variable following those 4 rules. So let me write our variable name. So we are going to write variable name as number. You can write anything you want. Now inside this variable, we are going to add one number. Let's say I'm going to store 44, and at the end you have to write a semicolon to end the command. If you don't write the semicolon, compiler will throw you one error. So this is how you can successfully create a variable. Now our variable named number, it is going to store our value of 45 between the 4 bytes. So our size of our integer data type was 4 bytes, means it will allocate 4 bytes of data inside our memory, and it is going to name those 4 bytes as a number, and it is going to store our 44 inside those variable. Now after creating the variable, now let's see, is it really storing that 44? Now we have to write the printf statement, printf %d. So these are the format specifiers. We will see in next video what kind of format specifier we have inside our C. Now let's just focus. After these double quotes, you can give a comma, and now we are going to use our size of operator, size of, and inside our braces I am going to give our variable name, which is number, and at the end we are going to write one semicolon. So this is it. So after these statements, you can now simply run our program. Now, as you can see here, is it printing size is 4. The 4 meaning that 4 bytes means, as we have told you, a computer can fetch is byte. So it is representing the size inside in bytes. So size of this number variable is 4. Means we have informed our compiler that we want to allocate 4 bytes of data which are integer type, and name that 4 bytes of data as a number. So our variable size have displayed on the output terminal. Now we can change size of our data types. Let's check them one by one. So let's check size of our char. So as you can see here, we are checking size of our char. So size of our char was 1 byte. So it has successfully told us size of our char is 1 byte. So we can go for integer also. Now if I try to print this size, let me just run this program. So as you can see here, it has printed size is 4 of integer. So we can try for all of them like float, and you can run this program. Now it has shown 4 as a size. So this size in bytes. And for double, as you can see here, it is printing size as 8. So this is based on 32-bit system. So for 62-bit system, it might show double size. So this is how we can use our size of operator to check our size of our data types and our variables. And this is how we can allocate a variable, and we can store data inside that variable with the assignment operator. So we are going to learn about these operators and which kind of operators we have in future videos. For now, please go and try this program in your computer, and let me know if you encounter any problem in the comment section. And please make sure, if you like this video, hit a like button and hit on the subscribe button for such videos. And thank you for now.